All right, so today we are dividing polynomials using long division. This is an extension of yesterday, where yesterday we did polynomials with monomials. Today we are going to look at polynomials divided by other polynomials. So what that means is we can no longer take everything in the numerator and divide it by the denominator. If the denominator contains a plus or a minus sign, then you cannot rewrite the problem so that the denominator is under each numerator term like we did yesterday. So today we're going to learn one method, which is long division. Long division works for all polynomial division by polynomials. Let's go through and just talk about the steps to doing long division and the process of how it relates back to division in the olden days. So in order dividing a polynomial by a polynomial, we need to use long division. If you think back to long division from third grade, that was the case in which you had something like 500 and 43 divided by, I don't know, maybe 46. So let's see if I can do an example of that on here for you. So what you did was you took that 3 and you divided it into the 5 and you said, okay, 3 goes into 5 once. So then you put the 3 down here because 1 times 3 was 3. And then you subtracted, so 5 minus 3 was 2. Then you took that remainder, brought down the next number, which was 4. You said, okay, 3 goes into 24 8 times. So 8 times 3 is 24. Subtracted it again. Oh, we got 0. That's kind of nice. You bring down the last term, which is 3. 3 goes into 3 once. So 543 divides by 3 181 times. So like I said, that's the third grade long division. What we're going to do now is say, okay, how many times does the divisor go into the dividend? And then you put that number on top. So, okay, kind of a lot of new vocabulary there for her, right? So let's kind of talk about what do each of those words mean. So, the dividend is what goes in the den of the dividing bar. The divisor is what we are dividing by. So that's what's outside. The quotient is our answer. And then if our answer isn't nice, we add to the quotient our remainder. So divisor is what we're dividing by. The dividend is the numerator. It goes in the den of the division. The quotient is what's up top. And then we add to it the remainder. So for long division, once you have it all set up, you take the divisor and you multiply it by the results of the quotient and then subtract them from the dividend. We repeat that process over and over and over until we get down to a point where we either have a remainder or a final answer. So let's take something like x squared minus 5x minus 24. We'll talk first about what are each of those parts. So again, the top is what we call the dividend. The bottom is what we call the divisor. And then our answer will be the quotient plus the remainder. So let's work this problem out. We're going to rewrite it so that we have the dividend inside. So you have x squared minus 5x minus 24. We're going to take the divisor and put it outside. And then we're going to take the same rules for long division from 3rd grade and kind of apply them to polynomials. What do I need to multiply x by to get x squared? Well, since I have one, I need another, so I need an x. We're going to take that x up top, and we are going to now multiply it just like we did before to get an answer down here. So x times x is x squared. X times 3 is 3x. And then what we do is we subtract that answer from the original. So x squared minus x squared is 0. Negative 5x and negative 3x is negative 8x. And then just like in long division from before, we're going to bring down the next term. So once again, what do I need to multiply x by to get negative 8x? Well, it's missing the negative 8. So we write the negative 8 in up top. Then we do our multiplying. So negative 8 times x is negative 8x. Negative 8 times 3 is negative 24. But we subtract our answer away. So a minus turns to a positive. A minus turns to a positive. So negative 8x plus 8x is 0. Negative 24 plus 24 is 0. So 0 plus 0 is 0. So we're happy because this problem has no remainder. Our answer is x minus 8. So again, that answer is called the quotient. So you could also rewrite it as all of this equals x minus 8. Let's look at another example. We have x squared plus 3x minus 40 divided by x minus 5. So, dividend, x squared plus 3x minus 40, divisor, x minus 5. Let's work on that quotient. X times x gives me x squared. Multiplying it back, you get x squared minus 5x. Changing our signs, we get negative positive. So you get a 0, and then 8x, and you bring down your next term, which is negative 40. Same question, what do I have to multiply x by to get 8x? I need an 8, so 8 times x is 8x. 8 times negative 5 is negative 40. So you get negative 8x and positive 40. So negative 8x and positive 8x is 0. Negative 40 and positive 40 is 0. We're happy once again. This answer has no remainder. Its quotient is x plus 8. Let's do one more like this. What do you multiply x by to get x squared? You multiply it by x. So you get x squared minus 3x. Change your signs. So you get 0 plus 10x. Bring down your negative 30. What do you have to multiply x by to get 10x? You need a 10. So you get 10x minus 30. Change your signs, and you get 0 plus 0. Once again, we're happy. No remainder. X plus 10. Now we know that no remainder isn't something that's going to stick forever. We also know that there's going to be complications when we do these problems. So far they've been really easy. In this example, we have two different things kind of happening. The first is I want you to notice this is now x cubed. The previous examples had been x squared. I also want you to notice that from here to here, we go from a cubed term to a linear term. Well, when we're doing a problem like this, we have to account for that missing term. So we're going to do something called placing a placeholder. And when we do that, it just means we're going to put in a 0h squared. So we could rewrite this problem as h cubed minus 0h squared minus 11h plus 28. And this negative 1, if you recall from our past examples, means the same thing as dropping it to the denominator. So that multiplication becomes division of h minus 4. So we have our dividend and our divisor. Let's get our quotient. So let's put h cubed minus 0h squared minus 11h plus 28 in our dividend. Let's put our divisor out in front. Now this one is a cubed and we start with an h. So that means I need an h squared. So then you get h cubed minus 4h squared. And this is why we needed that placeholder. Change our signs. You get a 0. Now we have a positive 4h squared. And we bring down just one term at a time. So we bring down negative 11h. Once again, what do you have to multiply h by to get 4h squared? We need both a 4 and an h. So we get 4h squared minus 16h. Change our signs. The first term should always pretty much zero out. And then you get 5h, and we're going to bring down that 28. So what do you multiply h by to get 5h? You multiply by 5. And then you multiply that 5 back to those terms out in front. So you get 5h minus 20. Change our signs. And we get 0 plus 48. That 48 is what we call our remainder. So when we write our answers, we like to write them as the remainder plus the quotient over the divisor. So our final answer is the quotient plus the remainder over the divisor. Okay. Be careful. This problem isn't division. This problem is set up. So this is what we did last week with multiplying. So this is just a review of the FML process. So you're going to take that first term and multiply it to the next first term. So you get 4x cubed. Then you're going to take it and multiply it by the 5. So you get 20x squared. Then we're going to take the next term and multiply it. So you get plus 23x squared. Then you're going to take the next term and multiply it. So you're going to take 5 times 23, and that would give you 115x. And then we're going to take the last term, so you get negative 16x, and then negative 16 times 5 would give you negative 80. And then all we're going to do is add like terms together. So you get 4x cubed, 20 and 23 gives us 43x squared. 115 minus 16 gives you positive 99x. And then a negative 80. So again, just be cautiously aware. In the example that happened on the page before this one, it had that exponent to negative 1. On this example, there's no exponent, so this means that we are multiplying the polynomials together. Okay, I know that was a bit of a long lesson. This is definitely a topic that isn't going away, and it's a little bit more challenging. So we're going to take it slow. We're going to really work through these problems and practice, practice, practice. So if you get stuck or my notes weren't enough, there is a link on this page to extra practice. I also turned that link into a PDF for you. So you have tons of resources. You can also reach out to me during our school hours. Thank you.